Welcome to my channel. My name is Opubo. For those of you who are new to the channel, I bid you welcome. For those of you returning, I bid you welcome back. Good to have you return. You are well appreciated. As always, in this channel, I present various ideas and designs of technologies, mostly from the Technology IP Bank of Enhanced Knowledge LLC, often integrated from several technologies already in the IP Bank and made available for adoption by the Adoption Brokerage Division. This presentation focuses on smokestack retrofit carbon capture technology and its role in conservation economy. Therefore, it focuses on mining the effluent of the smokestacks of fossil fuel burners for global health and wellness in an approach that allows break-even and hence not impact the governmental budgeting for social services or place extra financial burdens on corporations as to motivate layoff of staffs. Yet, at the same time, the focus provisions industrial volume, quantity, resource for enabling a conservation economy from the technological perspective. After all, carbon dioxide has been produced in large quantities for so many years from the burning of fossil fuel and discharged into the atmosphere. So from a conservation economic perspective, the numerous smokestacks venting carbon dioxide and other chemicals present a massive upstream reservoir from which to extract carbon dioxide and other content minerals for utilization in enabling of the conservation economy. Of course, the focus also includes establishing approaches that the citizens of a geographical space, community, region, or even a nation could adopt to use the technology as to ensure the sustaining of a conservation economy. Listen for a moment, however, before making a deep dive into the smokestack effluent mining technology. If you have not as yet subscribed to the channel, by simply clicking on the subscribe button below, I implore you to do so. Please click the button now and subscribe to the channel. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published. And also, of course, help me to more consistently continue to elicit the peace dividend of conservation economy. Now back to the presentation. By the prevailing civilization, and also supported by the existence lifestyle, carbon dioxide has been produced in large quantities for years from the burning of fossil fuel, though this has been blamed for changes in the behavior of the weather or climate recently. There are two camps formed now about the climate change question. One camp fervently believes such to be true, and the other camp just as fervently disagrees. However, somewhere along the way, there was a resolution to capture the smokestack effluents and implement a sequestration of the carbon dioxide. The approach would use a retrofit design that retrofits on the plants. The manner of carbon capture by various entities, however, have been as varied as the entities and also guided by the final object of disposal of the stack effluent so collected. One primary consideration regarding the design of any carbon capture method has been the metal vapor contents of the effluent, which are ordinarily dangerous to humans when breathed in. Hence, the retrofit process adopted by many entities and developed to capture the greenhouse gases that invariably are also laden with the toxic metal powder was guided by the disposal approach that had been pre-decided before the design. Besides, the retrofit and sequestration efforts were considered by the power generation companies as added expense and also of only markup over cost, with no financial benefit to the environmental or so-called clean coal enabler entities. So measures were taken to ensure that such does not happen, and the solution adopted to ensure that the entire effluent is disposed of and not necessarily segregated to separate out the toxic metal. So there was little motivation to perform full-scale separation of the components of the effluent. Such approach will be safe. It's not generally consistent with the attitude of conservation economy, which has the fundamental requirement of national beneficial utilization of every resource within a given geographical space. A more reasoned resolution to this divide then is to prepare, but not at the deprivation of the other needs of life. The approach then is simply let not the money invested be tied up in the performance. Instead, design the performance to get back out the money invested. In that regard then, take the effluent as a resource to be mined and mine the effluent for all it has and extract all for resource. Yet, just as importantly, effect actions such that should global warming, as claimed by many, be correct, then the actions also preemptively forestall that future, and so preventing of greenhouse gases emission from fossil fuel burner with the object of mitigating global warming or climate change, whatever the actual jargon is rational and sensible. The rational approach then is abiding the saying, hope for the best, but always prepare for the worst. In that sense then, the worst case scenario, of course, is to assume that the climate change issue exists and then prepare for it. If, however, it turns out not to exist, then nothing is lost. Of course, nothing is lost only in the conservation economic sense, because the actions taken impact the availability of funds that would otherwise be used for supporting other social services and life in general. So then, the design of the performance rests in the technology development and smokestack retrofit carbon capture technology as developed by the Adoption Brokerage Division has the capacity to fully mine all components of smokestack effluents and is as shown in the figure. Conceptually, the stack effluent is utilized as a resource from which the components, including the thermal contents, are mined for utilization either in context use or in prospective context use. The technology, therefore, is designed to mine the effluent. By design, the technology is integrated out of the technology IP bank technologies of air gas separation process, ions separator, thermotransducer power generator, and of course additional equipment not from the bank such as cyclone separators, storage tanks, acid scrubbers, and specialty high temperature heater called the slagger, and then the conical retrofit equipment that allows the entire technology to be adapted and retrofitted to the stack. The schematic drawing leaves out some of the designs. For instance, the power generation plant is not shown, and the retrofit mechanism affixing the process to the stack is also not shown. In any case, during operation, the stack effluent at exit from the stack flows into the conical retrofit and is directed to flow into the power generation plant built of the thermotransducer technology, which converts substantial quantities of the heat into electricity that is then fed into an inverter power source that conditions and supplies the right power electric for use on the process. The outflow from the power plant, from where the drawing is starting as designated by the lower line on the topmost left corner, then flows into the mercury extraction separator equipment, where the mercury vapor is condensed, collected, and pumped into a mercury storage tank, the bottom line indicating such. The outlet stream continues to flow, entering into the metal dust aggregator equipment. The effluent is then fed into a slagger where the soot dust are heated into slag droplets which get separated when force-fed into the cyclone separator. The metal dust aggregator, of course, aggregates the dust, the metal vapor, in the form of a dust and deposits them at the base of the equipment, which are then collected. The metal dust aggregator is designed with the company's ion separator and is effective at removing the metal particles. The slag is collected at the bottom of the cyclone separator while the rest of the gas exits at the top. The top outlet of the cyclone then flows into the acid scrubber. In the scrubber, distilled water is first aerosol mix sprayed into the gas, and then subsequently higher jet spray into the gas to cause droplet coalescence, as well as drive the droplets to the walls, where the droplets impact the wall and then roll down the wall. And the acids in the gases are then scrubbed, leaving only the nitrogen and carbon dioxide in the gas. The gas is then now clean of other substances and is fed into air gas separator unit process, and then separated into carbon dioxide and nitrogen. Admittedly, there is at the junction of the presentation a uniform acceptance that the technology as presented completely meets the requirements of geographical space practice of conservation economy, given the extraction of all materials from the stack effluent, hence availing the option for full utilization of resources for use in every other technology of the economy. The object of performance design has also clearly been met. The mining is effectively done. Mercury, dust, metal, the acids, the nitrogen, and carbon dioxide can all be sold to recover the operating expense plus profit that will cover the depreciation of the capital expense. Significantly, this mining operation is of a conservation economy because the technology effectively took centuries-old discarded effluent and processed it into useful resource that for utilization as raw material for other technologies. As a process technology, the material of construction are mainly steel, copper, and other minerals. Hence, the prospect of implementing this technology on the many smokestacks in operation also gives the promise of full reuse of all discarded process equipment, with caveat that some of them will have to be repurposed. So under the principles of conservation economy, this technology holds its own weight. Now then, if interested in licensing this technology, please send an email to me. The email address is put in the pinned link below, as are other useful information. Regarding licensing considerations, however, there are some notes that should be of interest. The power plant technology can be licensed separately for use in stack processing. The overall technology is designed to be encompassing of all effluent smoke contents, and as such may be too much in some cases, and so licensing may have to be tailored for specificity, and we are open to such constrained or well-defined specificity. The design of the technology is clearly has some variability, which obtains only from parallelizing some of the process equipment with slightly smaller but minimal equipment to meet the volume of processing, as is the norm of process designs. On this note, I thank you, and I appreciate your coming to listen and view the video, and hope and expect that you will consider coming back for the rest of the future technology presentations. The fact is, even if you do not care to adopt the technologies you come to view, the presentations you come to view, some might just change your perspective of life and society. Until the next presentation, I wish you be well.